Okay, so just an introduction to triple integral. Okay, so if you want to talk about triple integral, you must have an idea of integrating a function of single variable. So when we say integrate x with respect to x, okay, so you say the integral here is going to be x to the power 2 over 2 plus a constant c. Okay, that is indefinite integral. Then you must have an idea also the double integral. Okay, so having known how to integrate a single variable function, you can now extend your integration to the double integral. Now for double integral, you realize that you're going to need that. So the first one and the second integral. Now what guides the order is what you put inside. Okay, so if I say dx dy, I'm going to integrate first this whole function with respect to x, because this must come out as the integral, and then the brackets here, integral of x plus y with respect to x, and then you have y outside. Okay, so y is waiting, and as y is waiting, the inside y is treated as a constant. Okay, so regard it as a constant. So we're integrating a constant, we don't throw it away, we multiply it with the variable that you're integrating with. So what will happen now is we're going to have x squared over 2, the integral of x, okay, then plus yx. We don't put a constant here because we have dy outside waiting. So now we have reduced it now to a single variable. Okay, we're now just integrating with respect to y. But remember, there's x appearing. So that x appearing is going to be a constant as well. So treat it as a constant. So that when we integrate here, we have x squared over 2 multiplied by y plus y squared over 2x plus a constant. So at this point now, I can add a constant. Okay, so don't worry about the constants. We'll get back to how we can get the constants if we're asked to do so. Okay. So another question that I can give is another double integral. This time around, I want to use definite ones. Definite ones are the ones with limits, so they have boundaries. So we want to find the integral of 2x plus 3y dy dx with the limits 0 to 1 and 2 to 3. Now, what makes us know that these limits are for this, even if I haven't said y is equal to, because on the left, on the integral themselves, 0 to 1, I don't know if it is for x and y. But when I come here, these will guide me. So 0 to 1, this is for when I integrate with respect to y. Okay, so what will happen is 2 to 3 is going to wait, and then we have the integral from 0 to 1 of 2x plus 3y dy, and then we cross dx. So we'll first integrate the inside with respect to y, and then substitute, then come back and differentiate with respect to x, and then substitute the remaining limits. So here we're going to have from 2 to 3. So we have 2x. Okay, so here we're doing with respect to y. So we have 2 xy plus 3y squared over 2 all the way from 0 to 1 dx. Okay, so this becomes, we now substitute the limits. So I have from 2 to 3. We substitute 1 where there is y, we get 2x plus 3 over 2. When we substitute 0, we will be getting 0, 0 because we have y in all the parts. So what has remained now here, we integrate with respect to x. And you can see that when there are limits, if you have constant limits, when you integrate for the first time, you just remain with one variable. So this one now has become a function of one variable, and it's very easy to integrate. So I'll bring the integral here. So that will be 2x squared over 2 plus 3 over 2x. So this from 2 to 3, so that we have 2 multiplied by 9. When I substitute what is x, 3 squared, we get 9 over 2 plus 3 over 2 multiplied by 3. Then this whole thing minus, I now substituted 2 throughout. So I'll have 2, 4 over 2. So I'm doing this plus 3 over 2 multiplied by 2. So that this 2 here goes, this 2 here divides. So we remain with 9 plus 9 over 2 minus, inside here we have 4 and 4 plus 3, which is 7. So we just say minus 7. And this is giving us 9 minus 7, you get 2. So we have 2 plus 9 over 2, which becomes 4 plus 9 on top, which is 13. 13 over 2. So this becomes our integral. So if you have such kind of integrals, for us to get to the triple integral, you've seen that we need the knowledge for integrating a single variable function, then having double integral, and we've seen how to do double integral. Now we can go to triple integral. So triple integral, you want to integrate having 3 parts. So we have suppose we are from 0 to 1, from 0 to 2, from 0 to 3. And we have a function x plus y plus z. Dx, dy, dz. Okay? So we'll keep 0 to 1, we'll keep 0 to 2, and then open and take 0 to 3, integrate x plus y plus z, and then dx inside, and keep dy, dz. So these are waiting. So we have from 0 to 1, also have from 0 to 2, and then inside now, with respect to x, we are going to have x squared over 2 plus yx plus zx. So this from 0 to 3, and then dy, dz. So now we have from 0 to 1, from 0 to 2. Then we substitute, we have 9 over 2 plus 3y plus 3z. So what we have now, again, we'll come and close here. So the other one is just minus 0, so it's giving us less work. So inside, we're now taking y and close the z outside. So that we have from 0 to 1, the integral here, 9 over 2y plus 3y squared over 2 plus 3zy. From 0 to 2, z is still waiting. And what we get here, we have from 0 to 1. Then we are substituting 2, so we're going to have 9 because the 2 is going to cancel at the 2 which is down. So we have 9 there plus, so 3y squared over 2. When y is 2, we get 3, 4 over 2, so that we just have 3 by 2, which is 6. So we're going to have plus 6 here, and then plus 3zy, and y is 2, so again we get 6z. So this must be closed with respect to z. So the down one, the limit is 0, so when you substitute 0 throughout, we'll be getting zeros. So this should be equal to the integral from 0 to 1, 9 plus 6. There we get 15. So we have 15 plus 6z dz. So now it has become a single variable integral. So that is 5z plus 6z squared over 2. And integrating this one, so we just substitute now the limits. So we have 15 plus 6 over 2 minus 0, and this is just 15 plus 3, which is equal to 18. So this is just an introduction of triple integral, and you can see how we are building it. So I said with the first one, just integrating x. The second one, double integral. So we have x plus y, and with respect to x and with respect to y. So we did that in order. Then we have another example here where now we are dealing with a definite integrals. Then now we bring in a triple definite integral. So you can see, so next time I'm going to present on our Fubini's rule, the one that allows us to swap the orders. So if we have dx, dy, dz, under which condition are we able to start with dy, dz, dx? Under which condition? So I'm going to present that in the next lesson. Thank you. Please don't forget to share and like and subscribe.